Okay, so we continue with sequences and series for grade 12. We've looked at arithmetic sequences and geometric sequences and also quadratic sequences. So now let's dive deep into this chapter. We're going to look at the series for this and look at the sigma notations. So for arithmetic, we know the general formula is Tn equals to A plus n minus 1 times D. And the formula for getting the sum to n terms is, as you can see there, that's the formula. Um, this is the formula here. But Sn equals to n over 2 into 2a plus n minus 1 times d. I can also get to show you how this formula is derived. Okay. Then for geometric series, we have, for geometric sequence, we have this general formula along with this sum to n terms. Right? Sum to n terms, either you want to use this version or this version, whichever one you want to go with, it's absolutely fine. And we also have sum to infinity when the value of r, common ratio, is between -1 and 1. Okay, so the sum to infinity is a over 1 minus r. Whenever your value of r is something like 2 over 3, 5 over 7, negative 7 over 9, negative 1 over 3. For all these values are between -1 and +1. So then you can calculate the sum to infinity, right? And that type of series, we say it converges. It converges to this value that you'd get when you plug into the formula for sum to infinity. Then we've got the quadratic term, which doesn't have a formula for getting sum to n terms, right? Cool. Not to say that you might not be asked to calculate sum to, let's say, 5 times for this. Then you'd have to calculate manually, determine term 1, term 2, term 3, term 4, term 5, and then add them all up. Okay? Cool. Let's look at sigma notation now. So here's a sigma notation. The sigma notation, you read it like this. So we'll look at this one. We say the sum of all the terms of this general formula Tk from k equals to 1 to k equals to n. Okay, where n is an element of natural numbers. So n is natural numbers, counting numbers. Okay, cool. So that's how you read it. And then this one is the sum of all the terms Tk from k equals to 0 to k equals to n. Okay, and something important when it comes to sigma notation is knowing how many terms we're actually adding. All right, so let's calculate that number of terms. Number of terms, we determine it by taking the top value minus the bottom value and then adding 1. All right, so in the case of this one here, or rather, my bad, let's use this one. We would say top minus bottom plus 1. So here it means we're adding 3 times. Okay, and then for this one, number of terms would be top minus bottom plus 1. So here we'll be adding what? 5 times. I hope that's clear. So let's quickly look at an example here, some examples, and do some calculations. All right, starting with the first one. So we need to determine the value of this, evaluate this. All right, so we'll do it slowly, nice and slow, in maybe 2 methods. So first, we'll do this. We'll expand this. So we start off by substituting the first value, which is 1. We're starting at 1 plus. So this is our first term. Second, we continue until we get to 5. Finally, the last one. Let's see what this value is 2. 5 minus 3, 2. 10 minus 3, 7. 15 minus 3, 12. 20 minus 3, 17. 25 minus 3, 22. Then we add all this together. This one, because it had a few attempts, we can just easily do this, but also for educational purposes, for learning purposes. So, but if we have like 100 terms, it will be better if we use a formula, right? Because we can't be doing this manually. All right. So this is arithmetic sequence, and we saw the general formula for getting sum for arithmetic sequence is this, which I did say I'll show you how to derive it. So we'll still take a look at that. But for now, let's also calculate this using this version, this formula. Number of terms, which is the value of n that we're going to substitute, top minus bottom plus 1. So it's 5 terms. And we had what? 1. We had 1, 2, 3, 4, 5. Okay? So S5 equals to 5 over 2, 2. What is the first term? The first time we calculated it, it's there, 2. Plus 5 minus 1 times, what is common difference? It's 5. This value here, this one, okay? Or you can just calculate it there. So 5 over 2 into 2 times 2 plus 5 minus 1 times 5, and we still get the same answer of 60. Okay? And then for number 2, we have r equals to 0, 3. And the formula is 3 times 2 to the power of 3. So we can start off 3 times 2. We start off, is the sum of what? Of this general formula, 3 times 2 to the power of r, from r equals 0 to r equals 3. So we start off with this one, the first one, second one, third one, and then lastly, we stop where? Here, when r is 3. That's where we stop, right? So this one is 3 plus 6 plus 12 plus 24. Okay. Alright, 3 plus 6 plus 12 plus 24, we get 45. This is doing it the long way. But if also just to show how it works, but when the number of terms get bigger, it's better to do what? To use the general formula. And again, number of terms. And for that, we need to determine number of terms, top minus bottom plus 1. So we've got what? 4 terms. Those are the 4 terms, 1, 2, 3, 4, that we calculated initially. Right? So Sn equals to a times r to the power of n minus 1 over r minus 1. What is our value of r? We'll take 2 consecutive terms, 6 over 3, we get 2, which is this value there. Okay? Then, what is T1? Now, T1 normally is the value of A, right? But in this case, we need to calculate the value of A. Normally, the value of A is somewhere here, right? But that's not the one. So, well, in this case, I guess it still is. It happened to be 3. Sometimes it can be different, particularly when we're starting at some different value here, like something like 0 or starting at 2. So you need to make sure you calculate the value of A, which is the first term. Okay, so 3, r is 2. How many times 4? Minus 1 over r is 2 minus 1. And then sum to 4 terms. Let's see, with the formula we get what? 3 into 2 to the power of 4 minus 1. 2 minus 1 below here just gives us 1. So 45. We get the same answer. I hope that was clear. If you've got any questions or anything you want to share with us, please feel free to engage with us. So in the comment section. So now let's look at the derivation of this formula. Of this formula. So this formula comes from here. So we'll start off by determining Sn, sum to n terms. T1, we'll start off with T1. T1 plus T2 plus T3. T3 plus all those other terms up until Tn. Or Tn minus 1 plus Tn. We'll do this, and then we'll also do this again in the reverse. Tn plus Tn minus 1 plus all those plus T2 plus T1. We don't need this T3, but it's fine. So let's do that. Sn is T1 is substitute in the place of n, we substitute 1. That's going to be 0 times d. That's just a first term. We substitute 1 here. No, 2 for T2. That's 2 minus 1, which is 1. So the second one is a plus d. And then for T3, we substitute 3. 3 minus 1 is 2. 2 times d is 2d. A plus 2d. We stop. Last one. Now, what do we substitute in the place of n? We substitute n minus 1 in the place of n. There's still a minus 1 here and a d and whatnot. Right? So here we get a plus n minus 2d. For the last one, we substitute n in the place of n. So it's just, well, the general formula. Cool. And then we do the same in reverse. We're just going to copy that. We change the order here. We start with the last one. And then we have I'll remove this one. We don't need this one. So cool. So now we're going to add these two formulas together. This one is 1, this one is 2. So now we add 1, the equations together. We get Sn plus Sn, that's 2Sn. A plus this one. So we're going to add the first term with the last term, second term with the second last term, corresponding like that. They'll correspond like that. So here we get 2a plus n minus 1 d plus, so we added this. Now we add what? We add this. A plus a, that's 2a. D plus negative 2d. We are going to be left with minus 1d. Right? Um, 1 second. So we're going to do this. We're going to say a plus d plus a plus. All right. Let me go back. A plus d plus a plus n minus 2 d. Cool. We get 2a plus 2a plus that's going to be nd minus 2d plus d, which gives us what? 2a plus nd minus d, which is 2a plus n minus 1d. Right? So even here we get what? 2a plus n minus 1d. Okay? Then we continue. On this side, as you can see, we're adding the same things. This one corresponds to uh, the green. This one corresponds to the yellow color, will give us the same result. This one is the same as the green color, right? A plus D, A plus D, A plus N minus 2 times D. So we'll get the same result of 2A plus N minus 1 D plus 2A plus N minus 1 D. Right? So if everything in between here, all the terms, when we add them together, we'll get the same result. So we'll simplify this to what? 2Sn equals to, how many terms in total are we adding here? We are adding n terms. N terms with all of them have this value. So you can just do this, multiply this by n. It's like we're adding, let's say we're adding 1 how many times? Uh, 1, 2, 4 times. So this simplifies to what? 4 times 1. In this case, we're adding what? 2a in the place of 1. It's 2a plus n minus 1d. How many times? N times. Okay. Then we divide both sides by 2. And you get what? You get your general formula. And that's it for this lesson.